Hope that all is well, that you guys are doing fine at home. Again, I know it's a little crazy starting off the year the same way that we finished it, with being at home with remote learning and all that, but little by little, as long as we all keep getting there, and as long as everybody's safe and healthy and all your families are doing well, that's all that matters at the moment. So the other day we went over what to expect for the class and all that. What I wanted to do today is I wanted to start actually going over one of the most important topics that I feel for geometry before we actually start getting into the topics of geometry, and that's solving equations. And so with solving equations, I always need to make sure that my students can do it, just because it is one of those things that you will do a lot of in geometry. And if you know how to do it already, great. If you don't, there's nothing wrong with it. Again, we'll learn little by little, and we'll get you more comfortable with being able to solve equations without any issues. But today I wanted to just go over what you guys may know already, or just to reinforce all these lessons that you've had already on how to solve equations, and just to refresh your memory if anything else. So when it comes to solving equations, again, the one thing, and you've been seeing this for a long time, probably even in elementary school, when it comes to solving equations, the one thing you're always trying to do is isolate a variable, right? Get a variable by itself, and it can be any variable whatsoever. So let's start off with an example. Let's say that we had 3x is equal to, 3x is equal to, let's do 12, right? Now our goal is we want to solve for x. So if we want to solve for x, anytime you're solving for an equation, you always want to get the variable by itself. In this case, we want to get x by itself. And we know that x isn't by itself because right now, x relates to 3. So instead of having just x, we have 3x. We want to get x by itself, which means in order to get x by itself, we need to get rid of the 3. The way that you always get a variable by itself, you always have to do the opposite operation, the inverse operation, in order to get the variable by itself. In this case, we want to get rid of the 3 so that x can be isolated. And so in order to get x by itself, we got to get rid of that 3. Always realize, whenever you're always getting rid of a term, to get a variable by itself, you have to do the opposite, right? So if it's addition, opposite of addition is subtraction, opposite of subtraction is addition, opposite of multiplication is division, and so on. In this case, whenever we have a number next to a variable without any sign in between, so since it's literally 3x with nothing in between, that's always multiplication, always. If there was a plus sign in between, that'd be addition. But since there's nothing in between, it's just 3x, that's multiplication. And the opposite of multiplication is division. So to get rid of that opposite of multiplication is going to be, we're going to divide this by 3. And then whatever we do to one side, we always have to do the other side, because you have to do it on all sides of the equation, on both sides of the equation. Since I divided by 3 here, divided by 3 there, right? Now what happens here is those are going to cancel, right? Because opposite operation cancels out the term. So we have 3 divided by 3, cancels it out. We're left with x. And the one thing that I never want to confuse you with, but it is important to know, technically it doesn't cancel out, right? Because 3 divided by 3 is 1, right? But whenever we have a variable, there is always a 1 there. Always, there is always a 1 there. But since we don't ever need to write it, that's why we always say that it cancels it out, right? So we divided it, the 3's cancel out, we're left with 1x equals, and then 12 divided by 3 gives us 4, and we're done. Again, all solving equations it's just always doing the opposite operation to get the variable by itself. In this case, since it was 3x, whenever it's together, it's multiplication. Opposite of multiplication is division. So we divide both sides by 3. That cancels out to give us 1x, and then 12 divided by 3 gave us 4. And if you ever want to check your answer, you could, and we know it, because if we were to go back to the original equation we had, 3x equals 12, we know if we were to substitute x equals 4, we know that 3 times 4 equals 12. So we know we're right. But again, that's just a good way to check. You don't always have to do this. It's just me showing you all this, how to do it. So again, whenever you're solving equations, just always remember, most important step to get a variable by itself is always doing the opposite operation. Let's go to another one just to see that you guys are actually comfortable with this. Let's say that we had 2f plus 5 equals let's say 13, right? So again, our goal is still to get f by itself. And the one thing you always have to make sure of, whenever you have anything doing with the variable, always save that for last. So again, we have two terms now. We have the 2 and we have the 5. But since the 2 is with the variable, with f, we want to save that for last, right? Always save anything that has to do with the variable for last. So again, we want to get rid of the 2 at the end, and we also need to get rid of the 5. So first thing we need to do is deal with that 5. And again, whenever we want to get rid of a term, you always do the opposite. So we see the 5, we see that there's a plus sign. Opposite of addition is subtraction, right? So we're going to do minus 5, because again, opposite of addition is subtraction. And if we subtract 5 from here, we need to subtract 5 from there, right? So we see that those two cancel out. So what we're left with here is 2f. Okay? So we have 2f, which we brought down. That canceled out, so that's no longer there. We have an equal sign, and then 13 minus 5 gives us 8. Again, all I did was opposite of addition, which was subtraction. And if I subtract 5 on this side, I have to subtract 5 on that side. And then 13 minus 5 gave us 8. 2f came down. And now we're left with what we just finished doing, basically, which is we have 2f equals 8. We want to get f by itself, so in order to get f by itself, we've got to get rid of that 2. And think, whenever you have a number next to a variable with nothing in between, that's multiplication, always. And opposite of multiplication is division. So we're going to divide this side by 2. We're going to divide this side by 2. That cancels out, right? So we're left with just f equals 8 divided by 2 is 4. And we're done. So again, anything that's always with the variable, always save for last. Opposite of addition was subtraction. Subtract it from both sides, which gave us 2f equaled 8. And then opposite of multiplication is division. Divide both sides by 2, canceled out to just give us f equals 8 divided by 2 is 4. Try another one. Again, we'll do 3 more examples just to make sure that you guys are comfortable with seeing the majority of the types of solving equations. This is going to be basically the same thing. I just want to make sure that you guys feel comfortable with different signs. So we have 4m minus 5 is going to be equal to, let's do 7. Okay? Okay. You have 4m minus 5 equals 7. We have the 4 that we want to get rid of, and we have the minus 5 that we want to get rid of, just to get m by itself. Again, anything with the variable, save for last. So the first thing we'll get rid of is that 5, and be careful. Again, whenever you want to move something to the opposite side and do the inverse, do the opposite, you want to do the opposite operation. So the 5, since it's minus 5, the opposite of subtraction is addition. Right? So opposite of minus is positive. Opposite of subtraction is addition. We have 5 here, add 5 there. That cancels out. We have 4m equals, right? Brought down the 4m, brought down the equals, and we know that 7 plus 5 gives us 12. And so again, all I did was the opposite of subtraction was addition. And if I added 5 here, I got to add 5 there. That canceled out. Now we see again, we have 4m equals 12. Whenever we have a number next to a variable, that's always multiplication, since there's nothing in between. Opposite of multiplication is division. Divide that by 4. Divide this by 4. The 4's cancel out, and we're left with m equals 3. Because again, all we did was opposite multiplication, which was division. Divide this by 4. Divide this by 4. 4's cancel. 12 divided by 4 was 3. Again, it's always just a process of getting the variable by itself. And anything that has to do with the variable, always save for last. Always. Now, let's get to this one. So let's say that we were to have this. We have 2f, right, plus 3f plus 5f equals, let's do 20. Let me use a different marker just because this one's clearly dying out. So we have 2f plus 3f plus 5f equals 20. And so, difference here already is that all of them have f, right? And so sometimes people will see that and they'll start getting worried because they don't know what to do. They have to think that they have to solve it 3 different ways, or get rid of 3 different numbers, you don't. Since that's 2f, that's 3f, that's 5f, we can combine like terms because they all have an f. And so when you combine like terms, you're doing exactly what the operation is saying. So here it's saying we have 2f's, right? And that's all that means. 2f means you have 2f's there. We have 3f's here. We have 5f's there. And since it's telling us to add them all, right? It's telling us to add this 2f, it's telling us to add that 3f and that 5f. We know that 2f and 3f, so if we have 2f's and we have another 3f's, we have 5f's there, right? So that gives us 5f, right? Plus 5f there equals 20. And again, you can do all this at the same time. I'm just showing you this way. So again, we knew that 2f plus 3f was 5f, right? 5f plus another 5f is 10f, right? Because all we have is combining like terms. So we know that 2f and 3f is 5f. 5f plus another 5f is 10f. Again, just showing you that you could have done that all from the beginning, right? So I would say if you want to do this step, you could. It's completely unnecessary. But if you want to just combine everything all at once, feel free to do so, right? So we know that 2f and 3f is 5f. 5f plus 5f is 10f, right? And once you're here, it's just solving for f. Whenever you have the 10 next to the f, to the variable, it's always multiplication. Opposite of multiplication is division. Divide that by 10, divide that by 10. 10s cancel out, and we're left with f equals 20 divided by 10 gives us 2. And again, you're done. Because f is by itself, and we know that f is equal to 2. That's it. And again, if you don't like seeing this step, because I think that some people are looking at this and trying to figure out why I would do that, it's completely unnecessary. If you want to just combine everything the way that you can, feel free. Because again, 2f and 3f is 5f. 5f plus another 5f is 10f. And then it's just doing it the same way. I have one more problem that I want to do, just to make sure that you guys feel comfortable with all this, and it's accumulation of everything that we've done, right? And so, let's say I were to do this. Let's say that I were to do 3x plus 4 plus 2x plus 6 equals, let's say it's going to give us 4, right? Now, you have multiple terms. You can't just combine everything because some have x's and some don't. But what we can do is, again, combine like terms, right? And just to see that you guys are comfortable with it, we see 3x right there, right? We have 2x right there. Right? So with those two terms, we can combine them, right? And then we have the 4 and we have the plus 6. Since there's no variable, we can combine those two together. We can combine that, right? So we combine anything with x, we combine together. And then these two we combine because there's no variable. And remember, we're combining them because they're on the same side. If they were on different sides, you'd have a different process to do. But since they're on the same side, we can feel comfortable combining them, right? So we combine our x's, right? We know that 3x plus 2x gives us 5x's, right? And always just think of it that way. There's 3x's there, there's 2x's there, so total we have 5x. We're done with that, right? Cross that out. And now we can combine the 4 and the 6, right? Because 3x and 2x is 5x. We know that 4 plus 6, and notice how they're both positive. 4 plus 6 gives us 10, right? And now the sign that goes here, we know it's a plus sign. And the reason it's a plus sign is, again, we had a positive 4 plus another 6 gives us a positive 10, right? So the 5x was 3x plus 2x. The 10 came from 4 plus 6 equals 40. And again, all I did was just combine like terms, right? And now from here, it's exactly what we just finished doing before, right? You have 5x plus 10 equals 40. Anything with the variable, always save for last. So let's get rid of the 10 first, right? Opposite of addition is subtraction. So we're going to minus 10 from there. And if we subtract 10 from one side, you got to subtract it from the other side. The 10s cancel out, so we're left with 5x equals 30, right? And now once we're here, again, whenever you have a number next to a variable, it's always multiplication. Opposite of multiplication is division. Divide that by 5, divide this by 5. 5's cancel out, and we're left with x equals 30 divided by 5 gives us 6. Just that. And again, I want you guys to always feel comfortable with this. If you're great with solving equations, awesome. It's going to make life a lot easier in class. If you're not, again, we'll keep practicing with it throughout the year. We'll always make sure that your skills are getting better with it, and I'll always go over every single step if you guys need to. If you need anything, feel free to reach out to me, guys. All the best. Take care.